Hello, and today's purpose of the day is I can identify and generate geometric and arithmetic sequences. Let's look at the definition of a geometric sequence. A geometric sequence has its first term that is non-zero. So the first term cannot be zero. So first term is non-zero. And now let's provide a definition for what exactly a geometric sequence is. A geometric sequence means that each subsequent term is found by multiplying the previous term by a non-zero constant called the common ratio. So you're multiplying to get from one term to the next term. So multiplying by a common factor or common ratio. So I'll write each subsequent term is found by multiplying the previous term by a non-zero constant called the common ratio. And how we define the common ratio, or what variable, typically we use the variable r for common ratio. And then common ratio right below is found by dividing any term by its previous term. So if it doesn't just stick out at you that the sequence is multiplying by 2 or by 1/2 or whatever the common ratio is, we can find that by dividing any term by its previous term. An arithmetic sequence is a sequence that changes by a constant common difference. So instead of, for a geometric sequence, when we multiply to get from term to term, arithmetic means we are adding or subtracting or finding a common difference that's between the terms. So a sequence that changes by a constant common difference. Okay, now let's determine whether each sequence is arithmetic, geometric, or neither, and we'll explain. So as we look at this first example, 0, 8, 16, 24, 32, what is happening to those terms is that it is going up by 8, right? Each time it's adding 8, 0 to 8, 8 to 16, 16 to 24, 24 to 32. Let's fix this here so that looks a little bit better. I'm going to zoom in. So that's adding 8, right? Adding 8. So each time we're adding 8. So therefore, this sequence would be arithmetic. And then for explaining it, we could say common difference is 8, right? And common difference can mean what we're going, up by, what we're going, down by. And so if you even wanted to clarify a bit further, you could say common difference is plus 8. All right, let's look at B, 64, 48, 36, 27. So if it doesn't jump out at you that the common ratio is timesing by 3/4, and that's okay if it doesn't, but each time we're multiplying by 3/4, we could grab our calculator and take each term and divide it by its previous term. So take 48 divided by 64, you get 0.75. Take 36 divided by 48, you get 0.75. Take 27 divided by 36, you get 0.75. So each time we are going up by 3/4. So double check that on your calculator. Take 64 and times it by 3/4. You get 48. Take 48, multiply that by 3/4. you get 36. Do that again for 36 times 3/4. You'll get 27. So just a way to double check that you are making sure you have the common ratio right. So for our answering this one, we could say this is geometric, and the common ratio is 3/4. All right, C, 2, 8, 14, 22. So let's check here. It looks like we are adding 6, adding 6. Ooh, but then we're adding 8. So we are not adding the same common difference each time between terms. So this would be neither. We could say no common difference or ratio or common ratio. Okay, let's continue on. So find the next 3 terms in each geometric sequence. So we'll find the common ratio, then we'll multiply each term by the common ratio to find the next 3 terms. So we're getting told in the directions, it's a geometric sequence, so now we just have to figure out what the common ratio is, and then after we figure it out, find the next 3 numbers in the sequence. So this first one, 1, -8, 64, -512, is multiplying by -8. Right? Each time is being multiplied by -8. So I'll take my calculator, take -512 and multiply it by -8. So I'll get 4,096 times -8, -32,768, and then times -8 again, and get 262,144. Not too difficult. Part B, 40, 20, 10, 5. Let's do the same thing here. Let's figure out the common ratio and then figure out the next 3 terms. So it's multiplying by 1/2. Again, we don't want to say dividing by 2. We want to change that into a multiplication problem because that's what the common ratio means, what we're multiplying each subsequent term by to get the next term. So 5 times 1/2, and make sure you know how to do this on your calculator, right, gives us 2.5. Times 1/2 again is 1.25, and then 0.625. And it doesn't necessarily matter if you leave your answers as fractions or decimals. The directions will specify what to leave your answers in. Now we will be practicing writing the recursive formula for arithmetic and geometric sequences. We'll start with the geometric sequence. So the recursive formula states that, excuse me, a sub n, so that's what a little n says, a sub n equals a sub 1 times r to the n minus 1 power. So here, when we're writing the recursive formula, a sub n stands for, I'm going to zoom in a little bit more, the nth term in the sequence. The nth term, let's fix this, in the sequence. So find the 100th term, find the 1000th term. A sub 1 is the first term in the sequence. R is the common ratio. And n is a counting number. So we won't ever ask you to find the negative 100th term, right? We'll ask you to find the 100th term, so numbers that we typically usually count, which are whole numbers. Or we could use the formula f of x equals a times b to the x. That also is a geometric sequence formula. And what do you think each part means in that formula? F of x equals a times b to the x. Well, a, as you know from exponential functions, writing equations for exponential functions, a is going to be here our 0 term, right? Like the y-intercept. When you plug in 0 for x, what do you get for y? So 0 term. And B is your common ratio. So we could use the recursive formula a sub n equals a sub 1 times r to the n minus 1 power, or you could use f of x equals a times b to, or a times b to the power of x, excuse me. Both of those will give you the same answer by plugging in certain values into the function. Will give you any value that you're looking for in the sequence. So find the 100th sequence, find the thousandth, or excuse me, find the 100th number in the sequence, or find the thousandth number in the sequence. Both of these formulas will work to find any answer that you want. Okay, so let's look now at a few examples. Okay, so remember we could use either formula, a sub n equals a sub 1 times r to the n minus 1 power, or we could use f of x equals a times b to the x. So we can practice using both, and then really it can be up to you which formula you want to use. So let's look at example 3a. Write an equation for the nth term of the sequence and then find the 90th term. Okay, so if we look here, what's happening between this sequence as we are multiplying by -2? So -2, right, between each term. So if we write the recursive formula, so a sub n equals, okay, a sub 1, our first term, right, if we're looking at this formula, first term is -6 times the common ratio, which is -2, to the n minus 1 power. And then if I want to find the 90th term, I'm saying, okay, hey, a sub 90 to find the 90th term, that's just on the left-hand side to denote to the reader, hey, this is what term I want you to find. So a sub n equals, and then you type in your calculator. You type -6 times -2, -6 times -2, and then to the, we want to find 90th, so I'll type in 89 for my exponent, and we get 3.7, and then I get a whole bunch of decimals, so I'm going to round it to 3.7, and then I get e to the 27, which means on your calculator, e is times 10, scientific notation that we learned about, so times 10 to the 27th. Okay, so now let's check using the f of x equals a times b to the x, not the recursive formula, but the general formula, right? So general formula. So this would be f of x, excuse me, to fix a stylus, f of x equals, now this is, a is your 0 term, so -6 is your first term, so you have to work backwards to find that 0 term. So what times -2 gives you -6? Well, if you didn't know it was 3, take your calculator, take -6, and divide it by -2. So work backwards, and the 0 term is 3. So 3 times b is the common ratio, -2 to the power of x. So my calculator, I'll type in 3 times -2 to the 90th power. And I also get here, so f of 90, right? That's the 90th term I want to find. I get 3.7 and a whole bunch of decimals, but I'm going to round it to the 10th, so one place value, so 3.7. Then I also get E27, so that's times 10 to the 27th. So I still get the same answer using either of the formulas. Okay, using either of the formulas. Feel free to go over problem B if you would like to get an extra practice. Otherwise, we'll move on to arithmetic sequences. So for arithmetic sequences, there also is a recursive formula. This may not usually always be the most popular method to use because it's maybe not quite as efficient, but it still will work for any arithmetic sequence if you want to find, say, the 100th term or the 1000th term. So the recursive formula is a sub n equals, so that's again, a sub n represents the nth term in the sequence. So I'm going to zoom in here. So nth term in the sequence. A sub 1 is the first term in the sequence. D is the is the common difference. So what it's going up by or what it's going down by. and n is a counting number. So again, I'll ask you to find the 100th term, 1000th term, but never the negative 100th or negative 1000th term. And just like the geometric sequence, we also have another general formula that you could use for an arithmetic sequence. So, or you could use the formula y equals mx plus b. So what do you think each part of this equation means? Well, we know from the last section that linear equations are written in y equals mx plus b. So again, linear is a form of an arithmetic sequence, just like a geometric sequence is a form of an exponential function, right? We saw those same formulas being similar. So here, m represents, we usually think slope, but this will be the common difference. So what that function is going, or what that sequence, excuse me, is going up or down by. And b is we think of y-intercept. Well, it's the zero term, right? Zero term, otherwise known as the y-intercept. So let's look at the example. Let's go through one. We'll use both formulas. So write an equation for the nth term of the arithmetic sequence, and then we'll find the 90th term. So we'll find the common difference, we'll write an equation, and we'll find the 90th term. So we'll practice using both of the formulas. Okay, so we see negative 12, negative 8, negative 4, 0. So we know that's an arithmetic sequence. So I'd first figure that out, and it is. And so it is increasing by 4. So if I want to write my recursive formula, I have a sub n equals my first term, which is negative 12, plus, then I have n minus 1, right? That's part of the formula, n minus 1, and then times the common difference. And the common difference is 4. So now if I take that a step further, what I'm going to do is I get a sub n equals, I'm going to distribute this 4 to everything inside the parentheses. Even though it's written after the parentheses, that still represents the distributive property. So I have negative 12 plus 4n minus 4. Combine your like terms of negative 12 and negative 4 and get negative 16. So here, a sub n equals 4n minus 16. I can just rearrange that. Now, if I want to find the 90th term, I'm just going to plug in 90, right? So 4 times 90 minus 16, and I get 344 for the 90th term, right? 90th. Now, if I want to use my other formula, y equals mx plus b, we'll just go right over here, or f of x equals mx plus b, that means the same thing. All right, f of x equals my common difference of 4x, and then my zero term. So if I'm starting at negative 12, I need to work backwards. So what plus 4 is negative 12? Well, negative 16. And if you didn't know that, take negative 12 and add 4, subtract 4, right, to give you that negative 16. So this would be 4x minus 16, plug in 90 for x, and I will also get 344 for this example. So, I mean, you eventually get the same formula when you use both different types of sequences. The first one just takes a lot more to plug in to simplify, right? But it will still work. You'll still get the same answer. And feel free to do the next example if you would like additional practice with the arithmetic sequence. Thanks for listening. Have a great day. Bye-bye.